Well, we are live. Hello, 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 everybody. I am Vino. I am the developer advocate at Snowflake, and today we have a lot of ground to cover. We're going to talk about all things feature store in Snowflake. Super exciting for data scientists and ML engineers. And joining me today is Sandeep Gupta, who's the product manager. He has tons of great, exciting news to share and also a cool demo, I suppose. Sandeep, welcome to the show.
Thank you so much, Vino. Very happy to be here. Nice to meet you.
Nice to see you too. Long time no see. Definitely not at the green screen before this. Wait, what
Yeah,
brings you out today? What are you here for? I know Feature Store, but I know Feature
yeah,
Store has
uh,
been there for a while now. What is
yeah.
the
We
excitement today?
we have some exciting news to share with everyone today. We are announcing the general availability launch of the Snowflake Feature Store, and I'm here
Mhm.
to tell you all about it. We'll share sort of how this helps data scientists and ML engineers do their end-to-end ML development and operationalization of ML workflows, all inside Snowflake with the security and governance that our users expect from Snowflake.
Okay, that sounds cool. First, Feature Store goes GA. Second, end-to-end ML workflows in Snowflake. Sounds fantastic. Wait, what can you tell us about the GA announcement?
Yeah, so today we are launching the Snowflake Feature Store, which is a native product. It works inside Snowflake, which means that data scientists can now use this integrated platform for defining their features, for storing and maintaining them, for keeping them freshly computed and maintained as new data comes in, and then
Mhm.
make this as the single source of truth for all of their ML features and then serve features from the feature store so that you have the same consistent features being used in all of your machine learning pipelines. So actually, I can give you an example about this. Right? So let's say you are a financial institution or a bank,
Mhm.
and you have customers who have credit card transactions, and you have one data science team which is trying to come up with marketing campaigns for your customers or trying to figure out what is the lifetime value of the customers or what sort of offer would make sense to them. So let's say that data scientist might be interested in calculating something like the average transaction amount of this customer over the last 1 week or last 1 month. Now,
Mhm.
in addition, let's say you have a fraud detection team, and that fraud detection team also is interested in figuring out whether a transaction is fraudulent. Now, likely they would also be interested in a feature, which is what is the average transaction amount for this customer over the last 7 days or 1 month, right?
Mhm.
So instead of all of these data science teams defining the same feature over and over again and computing it in different ways with inconsistencies, with errors, with wasted time, you can now standardize all this in one place. You can have Snowflake maintain these feature pipelines for you as new data comes in. And you can now use that same consistent feature across all of your ML applications. So that is really the central problem that a feature store is solving for you. And by building everything in Snowflake, you get ease of use, you get maintenance, you get all the security and governance.
That is so cool. Sounds like something I needed when I was an ML engineer like ages ago, which was between different teams, say sales and marketing. Most of the times we spend a lot of time trying to understand what the KPI definitions even are. The data science and sales would have an entirely different definition, build their own feature stores and use it for their models. And then maybe somebody in marketing and finance would have their own KPI definition and use that for their own modeling. Sounds like with the feature store that could be solved, and we're all working with this one standardized set, if I can say.
Yeah, exactly. So that standardization is one central sort of benefit. The
Mhm.
other main benefit is that you want to make sure that the features that you are using, they are consistent as of the time that you want them, right? So in the case of like when you're training a machine learning model and you have this labeled data sets, right? Let's say you have labels, you have a transaction, you have a certain timestamp. You want to make sure that you are consuming the right features as of that time so that your models are accurate and that at production time, your models behave like they did at training time. Right? That is another thing that Feature Store guarantees is that it takes away all the hard work in
Mm,
making sure that you have time consistency between all of these features.
that's very cool. But now, if I want to maybe explore more about the announcement, maybe like start my building something, get my hands on feature store, is there anything you could share for us?
Yeah, absolutely. So let me show you what the key benefits of this are and what the Snowflake Feature Store actually supports. So Snowflake Feature Store really has three main components. It has some APIs that make it easy to define features. So this is where a data scientist would write their Python logic or SQL logic for computing features. Then from that, Snowflake now maintains these features, which means that as new data comes in, whether it's streaming data or whether it's data already in Snowflake tables, Snowflake will keep your features freshly computed on this new data, and it will provide you this self-maintained repository of features with all the correct timestamps. And then
Mm-hmm.
lastly, we have these very easy to use Python APIs from which you can serve features and you can create training data sets, you can retrieve features for inference, and all of these things are supported in the feature store. The other thing is we are super excited that as part of the GA release, there are lots of enhancements that our users will find in the product. First of
Mm-hmm.
all, we have a complete Snowsight UI integration. So and I'll show you this in the demo shortly, that you can interact with your features through the UI. We have a helper library that makes it very easy to author features
Mm-hmm.
and define these common types of aggregations that you want to do.
Mm-hmm.
We have integration with DBT and other tools like that. So this has been a much requested feature from our users because they are often building these data pipelines and feature pipelines on their own using tools like DBT. And our users were telling us that they don't want to recreate all of that infrastructure again in Snowflake. And so the good news here is that you do not have to rewrite anything. You just bring in your DBT pipelines and Feature Store will sit on top of that and let you use your features. We are integrated with universal search, which means that it's very easy to search and discover features in your organization and then reuse them. And then lastly, we have a new private preview capability for looking at end-to-end ML lineage. So when you consume features from your feature store, we can show you the complete lineage of which models used which versions of the features and where are those models in production and all of that.
That is so cool. Honestly, I feel like among all the new features and highlights, I really want to pick the top two, but it's super hard. I'm so excited about the end-to-end ML lineage because I know most of ML development is experimentation. You're always trying out with different feature selection methods, different algorithms, hyperparameter tuning. So it's like super helpful to have this end-to-end ML lineage. I cannot wait for that to go GA. Now, I have like little, maybe you would cover this in the demo that you already have, but like when I think about the feature store, it has the transform component into it. Do you mean to say that I could define my transformations and don't have to really write the transformation code every time? Is it like declaratively defined, or like how does this transformation component work?
Yeah, great question. So basically, you would write your standard data frame style operations in Python or SQL, and you would declaratively define them, and then Snowflake will create the self-maintained tables behind the scenes to apply those transformations. So actually, if you go to our documentation page,
Uh-huh.
on the documentation, there is this section called Common Feature and Query Patterns. So on
Mhm.
this page, we list out lots of common types of features that you can create. So these are, different types of aggregations or groupings, the row-based window features, and most importantly, sort of these lag features and time series features for, let's say, aggregating. In my bank example earlier, let's say you're trying to compute an average transaction amount, you can do those types of things very, very easily. And then you just specify this data frame logic and then create a feature view from this data frame, and then Snowflake will do all the hard work of keeping it freshly computed.
That sounds fantastic. And also, like as a follow up to that, I see as data scientists, or actually data engineers working with data scientists, you're running backfills a lot of these times. Say when there is a new KPI definition, you need to run backfill for the last 6 months of data to give the data scientists that feature data that they need. So what happens when I'm changing the definitions? Do I just add them into the
Yeah,
transformation pipeline?
that's a great question. So features are versioned in Snowflake Feature Store, so you can have different versions. So let's say I have a V1 of my customer features. Now,
Mhm.
when I want to introduce a new feature, I will just create a V2 of my customer features, or I could define a completely new feature. And then anytime you change your feature definition and you create a new version, then the first time that feature runs, it will do a backfill on all of your source data or the range of data that you specify, right? And so that will be a one-time job that will run, which will compute all these features. And then from that point on, they will be incrementally computed as new data comes in. But the key thing is that a feature version, you cannot change the definition of the feature. And that is to make sure that you have full reproducibility and you can go back to any point in time with your older features. But you can always define a new version.
Yep, I guess that makes sense. Maybe you like put that in as a new KPI definition and then start running it from there. So you have two immutable versions, because at the end of the day, that's kind of what we're going for, right? We don't, for
That's right. That's right.
reproducibility, you want immutable feature set.
Yes, and you don't have to redo what you did with the, let's say you have 10 feature columns and now you want to add an 11th one. You don't have to now recompute all of the previous 10. Let's say you could add the 11th one as a new feature view, and then at retrieval time, you can join the old features with the new feature. And then so you have all that flexibility in piecing together all these pipelines anyway that makes sense to your application.
Got it. Okay, basically like modularizing every piece of this puzzle,
Yes.
so you don't recompute anything at all. That's fantastic.
That's right. Yeah, that's a good way of saying it. Yes.
That is great. And I know we've talked about, all the great new features that's coming up as part of GA. And I know that the data scientists and ML engineers would be excited about it. But maybe tell me a little bit more about, I'm a data engineer. I might have to take up a little of the ML ops side of things going forward. We don't even have a feature store today. I don't even know what a feature store potentially even means because I'm a data engineer transitioning into ML ops. So what would I need to know? What exactly is a feature store? Why would I care? Or why should I use it?
Yeah, so I think we talked a lot about ease of defining features and standardizing them. Let's talk a little bit about sort of the retrieval side and the governance side, right? So the reason I would want in my organization a feature store to be used is so that I have this single source of truth. I have the features as versioned. I can see where the features are used. I can serve them and retrieve them with consistency. But more importantly, from a governance standpoint, these are all first class objects in Snowflake. So my feature views, entities, features, these are all first class objects. So I can do fine grained role based access control. I can control who in my organization, which role has access to defining and modifying features, and who has access to consuming features, right? So this is how you can bring in all of the same Snowflake Data Cloud governance into your feature store.
Gotcha. Then can I then use an existing standard Snowflake table as a feature store and define my own transformations and store it there?
Yes, exactly. So you can declaratively define any of the Snowflake operations, Snowpack operations with Python or with SQL, and you can use them in your feature store. You could also bring in your own created feature tables, and then in which case feature store would just be a view on top of your existing feature tables, and then everything will just work.
That is fantastic. I will probably take a quick minute or two to summarize what we've talked so far to, the audience out there. Firstly, drum rolls, please. Feature Store went GA today. Secondly, because now Feature Store is in GA, all the data scientists and ML engineers working with Snowflake are able to do end-to-end ML workflows in Snowflake, right? So you have the input data, it could be real-time data or batch data coming in from different sources, from different data sources. You can do the feature transformation defined declaratively in Python or SQL of your preference, and then have that stored and retrieved in the feature store. And it could also serve you during the training of the model on the batch training of the models. And that's pretty much it. Maybe can I talk about, once I'm defined, like, got the features, trained the model, life looks good now. But there is also this case of retraining the models, right? Because the data drifts all the time. The distribution of data set changes over time. And there is this whole monitoring the data, making sure the quality of these features are still, up to date. Like, how do I deal with that side of things?
Yeah, that's a great question. So Snowflake has this new capability called Horizon, the Snowflake Horizon catalog. And with that, there are these data quality metric functions. We call these DMFs, data metric functions. So these are available out of the box. There are lots of system metrics, such as, for example, is my data missing any values? Is there duplicate data? How many unique values do I have? What is the standard deviation or mean of my data, right? So these types of metrics are all available, and you can just simply turn those on your feature tables. And then you can set up your pipelines to kind of monitor or create alerts and thresholds based on when the data sort of exceeds or goes out of bound. And then that could be your trigger for your CI/CD workflows to now trigger, let's say, either defining, training a new model or something like that. So all of these capabilities are present. We are actually working on improving many of these things and providing them out of the box, so they are tightly integrated, and the data scientist does not necessarily have to build these types of monitoring sort of solutions on their own.
That sounds fantastic. So Horizon's coming in, helping us with the data drift and the monitoring the quality of the features that we have built in the feature store. So it's beautiful. Now, I feel like I have a lot of questions, but I would pause them for a bit now. Do you want to show us how one can work with the feature store? And then I will get to the remaining questions.
Yes, absolutely. So let me just bring up my notebook here, and I'm starting my session. Okay, we're all set. So what I've done here is I've logged into my Snowflake account, and I have one of these demo notebooks, which is our end-to-end example with feature store and model registry. You can find this example again from our documentation if you go here to the main feature store page and you go to getting started. All of these quick starts are listed here, and the one I'm showing you is this particular quick start. So in this example, what we'll do is we'll first just start our session. And then we are defining the schema we are going to use for our feature store as well as for our model registry. So feature store schema is where our features will live, and the model registry schema is where our trained machine learning models are going to live. Okay, so let's just create these schemas. And now the nice thing about this example is we provide out of the box 4 examples that are built in. So there are different types of examples here. There is an example for predicting airline delays. There's an example for city bike, New York taxi, and wine quality prediction. And so our users can run any of these examples, the source data, the feature definitions, everything is pre-packaged in this notebook for you. So in this demo, I'm going to run the airline features example. Okay, so when I run this helper load example, it's going to create all the source data in my Snowflake account. And I'll show you in a second what this data set has for this particular problem. So what we have in this data is we have 3 tables. So we have the airport weather station table. This is a simple table where we have some airport zip codes, and there are records of the rainfall in the last few minutes at that zip code location in millimeters with a timestamp, right, with the time at which that rainfall was recorded. Then we have a plain attributes table, and this is just a static table with different types of aircraft models and things like their seating capacity, etc. Right? So imagine if you're trying to predict whether my flight is going to be delayed, some of the things that might be relevant are what's the weather like at the airport departing location, and what type of a flight this is, right? Because if it's a smaller plane versus a larger plane, that might have implications on delay. So that's the reason why we are working with these 2 source tables. And then our main event table, this is really what, let's say, think of it as the transactional table or where the events are coming in. So this is our US flight schedules table, where for each row, there's a particular flight. So there's an airport name, there's a zip code, there are things like all other attributes about what plane it was. And then we have this label column, the departing delay, which is the ground truth label of whether this flight was actually delayed or not. And we have the flight schedule time, right? So this is my source data. So now I'm ready to sort of start modeling based on this data to try to see if I can predict this departing delay. So first thing I'm going to do is I'm going to instantiate my feature store. So all I'm doing is I'm just initializing a new feature store in my account. And then I'm going to create the main workhorse of a feature store, which are entities and feature views. Okay, so let me just run this and then I'll show you what's happening here. So entities are the underlying objects about which we are going to compute features. So in our case, one entity is the airport zip code, because we are going to have weather-related features for the airport zip code. Airport zip code is the unique key by which I can look up weather features. And then plane model is another entity because I have some plane related features. And again, the plane model is going to be my unique key to look up my plane related features, right? So all I've done here is I've defined these two entities. Next, what we will do is we will define some features. And again, now this is a toy example, right? So we're not like, don't think of it as a actual working high quality model. The purpose of this is to show you how the workflow is going to look like. So what we have done here is, by the way, the definitions for these feature views are in our open source repository. And so here I'm switching over to that and showing you what that looks like. So we have two sets of features here. So we have some weather features. And Vino, going back to your earlier question about how you write the logic. So you basically, I'm just writing here some simple SQL here in this case, right? And I could do the same thing in Python. So I'm basically selecting some columns from my source table. I'm summing the value of rain partitioned by airport zip code over a 30-minute interval, right? So I'm using the new Snowflake SQL function called range between, which is a very powerful way of computing these time series aggregates. So I'm just specifying that calculate 30-minute rainfall and 60-minute rainfall, and then define a feature view, which is going to take those two features, the 30-minute rainfall and 60-minute rainfall, and group them together as my weather features, right? And now when I do this, I can now add additional things like a timestamp column. I can give some meaningful description so I can easily search them. And I can choose a refresh frequency. And this is really important because what this means is that now Snowflake will keep this feature maintained with a frequency of 1 day. So every day, the Snowflake feature table is going to go back and see, do you have more events in your source data table? And it will recompute the 30-minute and 60-minute rainfall aggregates for you on a daily sliding window basis, right? So this is what is happening in this feature view definition. And now, so that we have defined these features, we can create these feature views and we can register them in Snowflake. So now if I go into my Snow site, let me jump to the feature store that I just created because I have some older feature stores in my account as well. So this is our feature store live demo. So these are the two features we just created. So I have my weather features. This has two features, the 30-minute rainfall and 60-minute rainfall. You can see that this is set up as a self-maintained dynamic table in incremental mode. If I click into this, you can see the refresh history of how many times this has been computed. And if this feature is being continuously running, you will see all of that refresh history. And you can also, sort of see all the comments related to your different features, and you can search for these in universal search. So now, having defined these features, let's consume these features and do sort of what feature store's main purpose is. So first part is we can use the feature store to generate training data, right? And the way this is done is extremely simple. So first, I'm just defining some columns that I'm just setting up my columns that this is going to be my timestamp column. I have a label column, which is the departing delay. I'm going to be joining features using these keys. And so all this skeleton information is used to first create what's called a spine data frame. And so think of spine data frame as just your skeleton data frame, which is going to be your training data set, right? So I will have lots of rows, and on each row, I have the zip code and the plane model, because these are the things which will determine what features I end up using. And then I have my label column, right? As well as I have my timestamp column. So using the spine, when I call generate dataset API, what will happen is that the feature store will retrieve the features based on this spine, and it will populate that into that data frame, and it will help create a training data frame. So notice what happened here. So I have the same original columns with the entities and their values, but now in addition, in my data frame, these three additional columns appear, which are my plane features as well as my two weather feature columns. And so these got automatically inserted by the feature store into your training data set. The data scientist did not have to worry about where is this feature coming from and is this the right value. Based on this timestamp, automatically the correct rain value was retrieved and populated in your training data. Right? So now that I have my training data, I can now train my model. And I'm going to skip that part in the interest of time. but this is just standard. Snowflake has very convenient training APIs to set up things like scikit-learn or XGBoost or any of your standard machine learning models. So we can train a model. Once we have trained the model, we can now log that model in Snowflake registry, and then we can run predictions.
Okay.
So
Yeah, sorry. Before we went with the model registry part of it, can we go
yes,
up in the notebook? I have a quick question. Because in the
yes,
initial data set, we had two types of data set, right? One was the weather data set and the other was the plain model. But we
yes.
created the feature views only on the weather data set to, calculate these two new features for the 30 minutes and the 60-minute rain in the past. But we did not do anything with the plain model.
We did. Sorry, I glossed over that a little bit. So here in this cell, we created the weather features and we also created the plane features. So it's just that the plane features are static features. So if I go back to my feature store, let's take a look here.
Mm-hmm.
So in my live schema, so you see these are the weather features we just talked about. In
Mm-hmm.
addition, I have my plane features. So if I go into the plane features, the only feature here is the seating capacity, which is a fixed feature. But
Mm-hmm.
you can sort of go and look at these feature values here. So if I do data preview, you will see that for all these different plane models, these are the seating capacities. So this is my plane feature. This is a separate feature table which got joined when I did the generate data set.
Got
But
it.
that's a great question. Yes.
So that explains. So I created a feature view for the weather dataset, and I created another feature view for the plain dataset, and these two got added to the training dataset when you built it. So anything that you
That's right.
define in the feature views is what would get added to the training dataset.
Correct, exactly. So when we said the join keys are these two things, it pulled features from both of those feature views. Yes.
Got it. Okay, that's fantastic.
Yeah. Yeah. So now, imagine we have finished our model training. What I next wanted to just quickly show you is that after you've done the training, your model will show up in the model registry. So this is a model that I trained last night on this particular example. And so I'm going into the V1 of my model. So this is my model trained with my airline delay prediction. Uh, Am I in the right schema? Yes, I am. And you see that this model exposes a predict function. It is taking as input these three feature values. It is taking the rain, some over 30 minutes and 60 minutes, and the seating capacity. So the data scientist doesn't even need to know what features my model is going to consume. The model is keeping track of that. And then if you go into lineage tab, and this is the preview feature I was talking about,
Mm-hmm.
you can see that this is the model I've just trained. This model was trained on this particular data set that we created from our feature store. If I
Mm-hmm.
expand the data set, you see that the data set actually comes from a source table and these two feature views, the plane features and the weather features. And if I expand the weather features and the plane features, I see the logic of where they are coming from. So I
Mm-hmm.
get this full lineage graph of this V1 version of the model is using V1 of my data set and V1 of my features and the source data tables. And this is how I can interact with the full sort of lineage of all of these attributes. This is one key benefit of doing everything in this unified platform.
Mm-hmm. I think this is a very powerful feature, going all the way back to the feature and then the raw data that the feature came from, and also the data sources where each of these raw data came from. Definitely helpful.
Absolutely. And in fact, if you have a stage, so our data was uploaded to a temporary stage, you can even see that here, right? And then in future, you'll be able to even see the downstream deployments and any prediction tables. So all
Mm-hmm.
of this will make it really easy and powerful to get the full end-to-end governance of your ML pipelines.
Got it. Okay, so that is very cool.
Yeah. So I think that's a quick demo. Hopefully you get the gist of it, but we have many more examples in our documentation and our users can go and check those out. And we'll also be publishing some more case studies for some of the common types of problems. But hopefully this helped clarify how the feature store works in Snowflake.
Mm-hmm. This was definitely helpful. And for those who of us watching, firstly, we will share the link to the specific notebook demo and Quickstart, even the link to the blog post for announcement. So you have all the resources that you need to get started, go build with it right away. And with that, again, you also saw that in the notebook, there is this model registry component of it. We didn't touch too much on that because, again, the focus of today was the feature store. But with model registry, the story of how you can build end-to-end ML pipelines and workflows in Snowflake is, fully complete. I feel like maybe I have too many questions, but maybe it's time I take some questions from the audience too. Are there any use cases for feature stores in data governance or data engineering? I think, Sandeep, before you even get started, I have like a personal take on the data engineering one, which I was just talking about. In one of my previous experiences, I built this unified metrics store. I could have
Mhm.
used really like any database table to do that, but then we used Feature Store to build that unified metrics store where we would collect data from all the different departments and define these standard KPIs using these transformation, like the transform feature in the feature store. And then it's essentially a feature store, but it worked as a metric store for us in that use case. But then I will let you also add more to this.
That's a great point. And yeah, you're absolutely right. So Feature Store can completely serve the needs of metric stores as well. And lots of organizations use them, particularly for their business analyst, BI type of use cases. So they're, you're not trying to train a machine learning model necessarily, but you're trying to maybe create reports or dashboards and things like that. And so yes, you do use all of this to do that. Um, for data governance, yes, so we talked a little bit about the compliance and auditability and traceability, and these are types of things that a data administrator needs to do. The other thing is that, let's say you have some privacy policies, you have some sensitive data, and you want to trace the lineage of that sensitive data. What features are trained using that sensitive data? What features are defined on that sensitive data? And what models are trained on that sensitive data? All of that is made possible by using these types of tools in an integrated fashion. Yeah.
Mm-hmm. Got it. And I know you briefly talked. Okay, this is my question now. I feel like this very important thing about I see a lot of DBT, developers in our community, and you briefly touched upon the fact that we support DBT integration. But then, can you talk a little bit more about it?
Yeah. So DBT is a very powerful platform for basically defining data transformation logic as code and then running that and then pushing down into Snowflake and orchestrating all of that. So with Feature Store, what you can do is you can keep those DBT created feature tables, so to speak, and then you still register them as feature views in the Snowflake Feature Store. We don't recompute anything. We don't incur additional storage cost because it's just a view on top of the DBT created feature table. But then the same APIs can be used to retrieve features and to create training data sets and to pass features to models for prediction. And we have a very nice quick start which walks you through that whole workflow with DBT integration in the same getting started section that I was showing earlier. And users can absolutely check that out and get started with DBT and Snowflake with Feature Store.
Mm-hmm. Awesome. That said, I will, go ahead and share the link to that quick start in the comments as well. That will be very helpful for everybody. And I feel like we are at the mark, but I would just ask this one last question before I let you go, Sandeep. If you have to say, maybe like give me like the top three reasons to kind of summarize or encapsulate this entire episode. Top three reasons why somebody should use the Snowflake feature store today.
Yeah. So I think feature engineering, data engineering, these are workhorse workloads. Every data scientist spends majority of their time doing these types of things. So doing all this natively in the platform where your data is saves you time, saves you headache, saves you a lot of complexity of setting up additional infrastructure. So I would say one, ease of defining features and hassle-free maintenance of features. Two,
Mm-hmm.
making sure that your features are fresh and consistent and the same values are being used with the same pipelines everywhere so that your models have a better chance of succeeding in production and things don't break or behave differently in production compared to in development. And three is all of the governance aspects that we talked about, right? Access control, sharing, replication, all of these types of things. So I think these are all the benefits that you get. And again, like Snowflake Feature Store is just one part of what you want to do with ML. I urge our users to check out everything else in the Snowflake ML portfolio. Uh, One quick thing, if I can take just 30 seconds, we have some very cool use cases where customers are beginning to combine Feature Store with Gen AI and even RAG applications. So imagine if you have like a chatbot type of a use case, but you want to enhance that with structured data features coming from your structured data. You can then pass in these features as part of your RAG queries and get potentially better results from these Gen AI models. So there is a very nice blog post and case study that one of our customers has published. So there's some exciting use cases that are stretching the boundary of what all you can use this for.
That sounds fantastic. I'm probably going to bug you offline to get a link to that blog and also the Quickstart perhaps. But that said, thank you so much for being a wonderful, wonderful participant on the show, telling us all about Feature Store and showing a cool demo of it too.
Thank you so much, Vino. It was awesome chatting with you on this and sharing this. Thank you.
Thanks, everyone. I will, as promised, share all the links to the resources and everything in the comments. I hope you have a good day, good evening, wherever you are signing in from. Thanks, everyone.
Thank you.